Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hazib bin Rusli, and for our experiment today we will be doing flywheel apparatus. Instead of using the actual apparatus, I'll be using equipment that I have, which is a bar and weights. Let's not wait around and start our video. Firstly, measure the dimension of the disc and axle by using proper instrument, and then repeat the measurement and take the average result. Mark a reference line at the end of the axle. The reference line will be used to record the number of turns of the axle. Put the weights at the end of the hanger, and then wind the string around the axle and record the number of turns. Record number of turns from the lowest point where before it touches the ground and the highest point before it touches the bottom of the axle. Make sure that the hanger and the axle doesn't collide. Add more weights to the hanger. Release the weight at the highest point. Record the time taken for it to reach the lowest point. Keep note to monitor the number of turns so that it doesn't exceed the number of turns that we have recorded earlier. Repeat the steps with more weight. Referring to the table above, using theoretical formula, the results is different compared to the experimental data. This is because theoretical formula take gravity into account and not for experimental. The moment of inertia of the system increases as the load increases. Hence, we can conclude the bigger the mass, the bigger the moment of inertia. There is slight difference in the percentage error. This may be due to less accurate measurement. There is a few causes of errors that may affect the result of the experiment. The first is equipment. The equipment that are being used during the experiment is important because it can severely impact the errors in measurement results. Second is the environment could also influence on the errors in measurement results. Variables such as gravity, pressure, stress, strain, elevation could impact the measurement results. Therefore, make sure to take the average of the measurement data before writing the final data. Third is the method. The method that is being used when taking measurement influences uncertainty, therefore it is the best to use one general method. Finally, the person who's taking measurement influence a lot on the results. They need to have the ability to facilitate the measurement process and perform a good work because it will impact on the measurement results. In conclusion, all of the objectives have been met. Firstly, we have verified Newton's second rule for rotational motion, which is torque equal to moment of inertia times angular acceleration, and the remaining objectives, which are calculation, are done. While doing this experiment, we need to make sure we get the most accurate data when measuring. A few tricks to achieve this by putting a platform under the apparatus above the floor to decrease the height so it will be easier for us to take the time when the weight touches the bottom. Another trick is to measure the tip at the bottom of the disc and the top of the weights to ensure all of the weights are set at the same level. Last but not least, have at least 2% to this experiment. One to drop the weight and the other one to take the time. This will let the person who takes the time to focus on the weight when it touches the lowest point.